Welcome to the last section that we'll be covering in Math 95 this semester, and this goes into a new and different type of function which we only kind of scratched the surface on to help you get ready for Math 102. And these are called logarithmic functions. Now, logarithmic functions are kind of notorious for being real difficult, but the applications that we're going to do with these are not necessarily really difficult. And the reason we use logarithmic functions is because when we have to find an unknown that is an exponent, we used to have tables that would enable us to do it, but at least for today, the functions that we're going to be using, we're pretty much going to just rely on good common sense and what we know about numbers to help us find missing exponents or missing parts of things that are in logarithmic functions. Today we have calculators which will calculate a good deal of this for us, but we still don't know how to use the tools of logarithms, so we don't need the tables, and we can still find missing exponents or missing values in more complicated equations. So let's kind of dive into this. So let's say, for example, I have 3 to the x equals 9. So what we would do is, now some may look at this and say, well, x is probably 2. But sometimes maybe 3x is equal to 8 or 3x is equal to 6, and the answer is not real obvious. We used to put this into what we call as a logarithmic form, and then we refer to the table to get an exact or an approximate value for the exponent that yields this. So what we're going to do is we're going to convert this exponential form into a logarithmic form. And what I do when I do this is, well, we're going to start off with a log. And a log is going to have a base in it. So we start off with a base of 3. We're going to start from here. I'm going to write that 3 below in the log. So what we're showing now is what a logarithmic function looks like and what is the notation of this. So we go log of base 3 to the 9. And I'm going to write a 9 over here. And then I'm going to go up and say this is going to equal the value of x. So when I write in logarithmic notation, I start with log to the base 3 of 9 is equal to x. So log to the base 3 of 9 is equal to x. So you notice here that what is unknown in the logarithm, or what the log of base 3 to the 9 is the exponent when this is written in exponential form. So a bit of a language shift here. You're hearing exponential form, logarithmic form. Let's go ahead and take a look at this in logarithmic form and see how we'd put this back into exponential, which is going to be the body of the work we do today other than solving the logarithms. So let's say I have the log, and we'll go ahead and make this 2 to the 16, and we're going to say that equals x. So what we're going to do in order to write this in exponential form is we're going to start at the base 2. So I'm going to write this as a base 2. I'm going to kind of do the same line trick where I shift to the right and then to the left. So I'm going to go log to the 2 to the x equals 16. So I use this trick of kind of using this line going from right to left, of going from exponential into logarithmic, and then from logarithmic to exponential. So the same trick kind of works here. So what we're going to do now is kind of look at this, and what really helps when you're doing this kind of work is to, first off, being able to write something from logarithmic to exponential form, and then using the math analogy you have to help simplify this. So we're going to be focusing a lot on rewriting logarithmic form to exponential form and then solving the problem. So let's go ahead and start in the questions on number 9. We're going to be working through quite a few of these questions pretty quick, because once you get the gist of it, it's not really terribly bad. So let's take a look at number 9. We're going to be asked to simplify this result. So we're given log the base 10 of 1,000. Now, some students may have difficulty seeing what this is going to be right away. So one thing you can do is you can go ahead and set this equal to x. So if I have log to the base 10 of 1,000 equals x, I want to know what the value of this is. So I want to know what log to the base 10 of 1,000 is. So I'm going to put an x there. Let me go ahead and rewrite this now in exponential form, where I have 10 to the x is equal to 1,000. So one way that can help me do this really fast is, well, I know that 1,000 is equal to 10 to the third. So if I have 10 to the x is equal to 10 to the third, I can therefore say x is equal to 3. So the value of the log base 10 of 1,000 is just 3. And that's our answer for question 9. Let's continue to press forward. We'll take a look at number 10. So number 10 is going to be log the base 10 of 100. So 10 raised to what exponent will give you 100? Hopefully most people can see that's 2. But let's say you didn't. We'll go ahead and set that equal to x again. We'll write this as 10 to the x is equal to 100. And kind of separate this from our previous work. Well, again, I can write 100 as 10 to the second. And since 10 to the x is equal to 10 to the second, x is going to equal 2. So log of base 10 to 100, that's equal to 2. I'm going to keep going with a bunch more examples here just so you kind of get the gist of what this is like. So let's go forward. So we have 12. Log the base 2 of 8. Well, let's say 2 to what exponent is equal to 8? Hopefully most of you people know that it's 2 to the third. Don't say it's 2 to the fourth. Let's go ahead and put an x there. Whenever I write this in exponential form, that's going to be 2 to the x is equal to 8. Hopefully most of you know 8 is equal to 2 to the third. So if 2 to the x is equal to 2 to the third, then x is equal to 3. And that's what we're looking for. Log of the base 2 of 8 is 3. Go to 14 now. So we have log the base 3 of 27. We want to know what the value of that is. So 3 raised to what exponent is 27? Hopefully most of you know that's 3. But if I write it as such, I can write this now as 3 to the x is equal to 27. Hopefully most of you know that 3 to the x is equal to 3 to the third. And therefore x is equal to 3. Seems to be a common answer. You'll find that from most of these, most of these exponents are going to be pretty low. Try to make these fairly simple for you to solve because, again, this is just an introduction into this. Okay? But these will get a little trickier as time goes on. Let's go to 16 now. We have the log, the base 4 of 1 over 4, and we're wondering what that equals. So let's go ahead and set that equal to x. If I write that in exponential form, we have 4 to the x is equal to 1 over 4. Well, the way we can write 1/4 as the value of 4 is if I take 1 over 4 and I raise it to the negative 1, I would flip it. So the one way I can write this now is 4 to the x is equal to 1/4. Let's see, not 1/4 to the negative 1, because it's 1/4 to the 1 right now. But if I want this to be 4, I'm going to make this to the negative 1. So 4 to the x is going to equal 4 to the negative 1, because 4 to the negative 1 is equal to 1/4. So if 4 to the x equals 4 to the negative 1, x equals negative 1. We're going to go ahead and keep going with this, because like anything else, oftentimes it's just a question of repetition to let a concept kind of sink in. Let's go to question 18. It's going to be log to the base 7 of 1 over 49. So how do I get 1 over 49? So let's go ahead and set that equal to x and write 7 to the x equals 149. Well, I get 1 over 49 using 7 by taking 7 and raising it to the negative 2. And that being the case, then x has to be equal to negative 2, and that's the value I'm looking for in question 18. Let's go to question 20 now. We have log the base 5 of 125. We want to know what that is. Again, if I set that equal to x, I know that 5 to the x is going to equal 125. Well, here I'm going to know, well, let's see, I can write 125 as 5 to the third. And if that equals 5 to the x, then x is going to equal 3. So, not so bad. Let's take a look at 22, just a little bit of a trick going on here. So this is going to be log the base 7 of 1. Well, what is that? Let me go ahead and set that equal to x. So 7 to the x equals 1. Well, how do you get that? The only way you can get 1 with a base of 7, the sum of the x has to be equal to 7. Well, what's going to give me 1? Has to be 0. So x is going to equal 0. So log to the base 7 of 1 is equal to 0. Just making sure that is in a clear view for everyone, that everyone can see that nice and clear. Hopefully that looks a little better. Let's take a look now at 24. We have a log the base 8 of 8, and we want to know what that equals. So let's just set it equal to x. That means 8 to the x is equal to 8, and writing that in exponential form. Well, the only way we can get this reasonably is to say that 8 to the x is equal to 8 to the 1, and x equals 1. So log of the base 8 of 8 is just 1. 26. Let's see, another question very similar in flavor. So we have here, this one is kind of ridiculously simple. Log of 9, log of the base 9 of 9 to the 10th equals x. So when you write this out, you may say, well, 9 to the 10th, yeah, it's a little strange. We'll just write it down in exponential form. 9 to the x is equal to 9 to the 10th. I mean, it's right friggin' there. X is equal to 10. No more simplification is going to be needed. Let's go ahead and take a look at 28 now. This is going to be log the base 10 of 0.1. Set that equal to x. Well, 10 to the x is equal to 0.1. Well, that's 1/10, so maybe it'll help to kind of see that as a fraction better, because you should recognize that 1/10, we get that by taking 10 raised to the negative 1. So x is equal to negative 1. Okay, going forward with a few more problems in this vein. We're going to take a look now at question 30. We have here the log, the base 16 of 4. We want to know what that's going to equal. So we'll set it equal to x. So we have 16 to the x equals 4. Okay, so how do we get that? Well, in this case here, what I'm going to do is I'm going to change this around a little bit now. Okay, so there's a couple ways you can approach this, but I'm going to write this 16 as a 4 squared to the x equals, and I'll just write this as 4 to the 1. So what's going to happen here now is I take the 2 and the x, and I'm going to write this as 4 to the 2x equals 4 to the 1, which means now I'm going to get 2x is equal to 1, or if I divide both sides by 2, I get x is equal to 1/2. And that's going to be the value we're looking for here. Another possible approach you could take with this from this point, so let's go ahead and just kind of copy this over again. So it just depends on how you do this, is I can write 16 to the x as being equal to 16 to the 1/2. And you'll see right away that we go straight for the solution in that case, but not everyone would see that particular method. And sometimes this method is the only technique that we can use to simplify a question, just depending on how involved the question is going to be. Let's go ahead and take a look now at 32. And 32 is going to be the log, the base 27 of 9. We're going to go ahead and set that equal to x, and let's see how we can manipulate this. So let's put this in exponential form. 27 to the x is equal to 9. Well, 27 and 9, there's not a common base for one or the other per se. But between these, we can rewrite these a little bit differently. For example, 27 and 9 share a common base of 3. So 27 I'm going to write as 3 to the 3rd raised to the x. And I'm going to say that 9 is equal to 3 to the 2nd. So I'm going to take the 3 and the x and multiply this here. So this is going to be 3 to the 3x. And that's going to equal 3 to the 2nd. Now that I have a common base with these exponents, I can set 3x equal to 2. So here's where it gets a little trickier. Now I'm going to divide both sides by 3, and I'm going to get x is equal to 2 thirds. So for this result, we find ourselves manipulating both sides of the equation to find a common root for 27 and 9 and 3, and having to do a little work using the rules of exponents to help us simplify this. Let's go ahead and take a look at one more problem from the first section, and then we'll take a look at the problems we have to do later. So this is going to be 34. So 34 is going to be, oh, I actually did 34, guys. This is going to be 32. So on the other side, I did 34. So just to make a quick change there, this is going to be 34 here. I'm going to do 32 now. So let me just kind of cross it out so this is clear. So 32 is going to be log the base 16 of 64. And I want to know what that's going to equal. The way this is done is very similar to the question we just did. When I write this in exponential form, this is going to be 16 to the x is going to equal 64. Well, 16 to the x, well, now these have a common root of 4 too, but I'm going to go with 4 because that's an easier one to deal with. So I can write 16 as 4 squared, and I put the x outside, and I can write 64 as 4 to the third. Simplifying this a little bit, I'm going to get 4 to the 2x equals 4 to the third. So I can set 2x is equal to 3. And then if I divide both sides by 2, I get x equal to 3 halves. So the log of 16, base 16 to 64, is equal to 3 halves. Okay, so those are the first type of questions that you have here. The second part of logarithm questions are going to go over. Since we don't use a calculator in class, we're going to be skipping a number of the types of problems that we have here. You should have an opportunity to use calculators in 102 to do a lot of the work that you have to use with logarithms. But again, I'll leave that to your teacher in 102 to build on further with you. So we're going to go to the last set of problems between 98 and 110, and let's see how we solve these. So 98 works as follows. You're going to be giving a logarithmic equation with all the values here. So, for example, log the base 4 of x is equal to 3. So this is basically the same technique we've already done. We're not subbing in for x. We're told what the log equals. We're just going to write an exponential form and see what we have to do. So when I write this in exponential form, I get 4 to the third is equal to x. Well, if 4 to the third is equal to x, 4 to the third is 64. And we have our number. Done. Going on to 100 now. We have log the base 4 of 64 is equal to x. So we're kind of given an unknown here. But they don't, we don't have to set it equal to an unknown. It's already done. So when I put it in an exponential form, I get 4 to the x is equal to 64. Again, I'm going to do what I did in the last problem because I think we did this exact problem. We have 4 to the third here. X is equal to 3. Going on to crank out a few more of these, I have 102. I have log of x, base s of 81, is equal to 2. So I'm going to go ahead and write this in exponential form. You get x squared is equal to 81. Now, if I take the square root, so go ahead and write this down. If I take the square root of both sides, one thing you need to know is that logarithms are only going to have positive values. Now, you may get some type of, I'm trying to think if you can get, yeah, I suppose you can get a negative exponent here. We got some negative values. But over here, we're only going to work with positive values or positive bases. So we're not going to work with anything negative, which is why we have the result of x equals positive 9 only. So we don't include negative 9 in this. 104. This is going to be log of x, base x of 8 is equal to 1. So when we write this in exponential form, this is going to be x to the 1 is equal to 8. Well, let's see. If x to the 1 is equal to x to the 1 is just x, so x is 8. I mean, that's a really easy question. So simple, you could easily overlook how to obtain the answer for this. A few more problems to finish off this lesson, and for that matter, finish off the semester. 106. We're going to have log the base x of 11 equals 1 over 2. So what we're looking at here is x to the 1/2 is equal to 11. If I want to solve for x, that means I'm going to need to square both sides of this. So you may want to write down what I had originally had there before I squared both sides. And then x, because 1/2 times 2 will be 1, will be 121. And there's our answer for 106. 108, we've got log the base 2 of x is equal to -1. So we can have the -1 over here, but we can't get anything negative here. So when I write this in exponential form, we have 2 to the -1 equals x. Well, remember, 2 to the -1 is just going to be 1/2. I just put a 1 under that, I flip it, and there's going to be my solution for 108. Last problem is going to be 110. Log the base 8 of x equals 2 over 3. So when I write this in exponential form, this is going to be 8 to the 2/3 is going to equal x. So remember what we did with this before. I kind of split this up, so we take 8 to 1/3 times 2. So I take the third root of 8, which is going to be 2, square it, and that's going to give me 4. And that's going to equal the value of x. So this goes back to the work we did back, I believe this was chapter 8, when we did the work on exponents. It might have been the earlier part of chapter 10 too. But feel free to ask me about questions about this in class. And that concludes our work with logarithms. And as a matter of fact, that's going to conclude our work for the semester. Please take some time to look at this and ask questions in class so that you have a good understanding of the basics of lower algorithms before you go on to your next class in 102 in your next semester. Thank you, and it's been good doing this class for this semester. I hope you benefited from it.